Hi guys, this is an introduction to the CAN bus that we'll be diving into for the next couple of weeks. The aim of this video is to give a short introduction to what CAN bus is all about, what it may be used for, and try to exemplify what layers of the OSI model is implemented by CAN controllers. Also, I will give a few characteristics of the bus that you can use to benchmark it up against other communication forms. The CAN bus is actually invented as a vehicle bus standard to allow microcontrollers and devices to communicate with each other without a specific host computer, but from one master device to another. CAN is built around a message-based protocol that was designed specifically for automotive usage. The protocol was invented back in 1986 by Bosch, and the first CAN chips were available from Intel and Philips back in '87. During the years, the protocol has had some revision changes, and the latest protocol, that is also the one used today, was published in 1991. The CAN bus is a two-wire multi-master serial bus standard that specifies how a system comprised of CAN nodes should be operated and how you should implement both the electrical and some of the controller features. To communicate on a CAN bus, you need as a minimum 2 nodes so they can speak with each other and establish a network. Each node in the network is able to both send and receive messages, but not simultaneously, since we only have one wire pair allowing data communication in one direction only at the time. A typical CAN bus setup would look like on the figure shown above, where you have CAN node 1, 2 and 3. Each node is made up of a microcontroller with a CAN controller on board. This is also inside our microcontroller kits. Apart from that, we need a CAN bus transceiver that can push data onto the bus. We have CAN node 2 and 3 next to CAN node 1. These are able to communicate with each other, assuming we have the same settings for baud rate and other things that can be configured. The physical bus itself is a twisted pair cable, typically with a 120 ohm resistor at each end. I know it looks like it only has 20 ohms at the left, but it has 120 in each end to terminate the bus and allow data transmission. So, to sum it up a bit, CAN is a multi-drop, multi-master serial bus that provides communication between different controllers, sensors or actuators. Well, since it was invented for cars, it can be engine control, or it can be lights or brakes or whatever needs to be operated on a CAN bus. It's very reliable and robust. It's a well-proven technology because it has many years in the field right now. It allows us to transfer data up to 1 megabit per second as a maximum baud rate, but we can also run much slower. Each data object or each piece of data sent on the bus contains up to 8 bytes of data payload plus an ID. CAN was again originally invented for automotive usage, so to make the wiring a bit less complex in a car or an engine department, like engine department shown here, to reduce the number of cables and to allow more data to run back and forth using only one set of twisted pair cables between the different sensors and the central engine controller units. Apart from automotive, it's used in industrial systems for connecting machines in a factory floor, in military, in agriculture on machines, medical usage because it's very stable and has a good transmission security. You can use it in smart homes and in general also in noisy environments. And hereby noisy I mean electrical noise, because CAN bus is rather immune compared to other field buses that we have looked at, or buses like SPI and I2C and UART. They are not really that immune, but we'll get back to that. So in general, distributed embedded systems can benefit from a CAN bus. If we look at the OSI model, that we have went through previously. We have the 7 layers that you know. CAN bus or a CAN bus system, including controller and PHY as shown in one previous picture. It implements layer 1 and layer 2 of the OSI model. Layer 1 is the physical layer that needs, it needs an external transceiver that you have to work with in order to send on a bus. But the controller implements some of the layer 1 functionality and the entire layer 2 functionality, where we can gain access to the bus, we can set up some frame formats, we can set up some filtering, addressing, and handle transmission, security and retries and acknowledge, and a lot of other things as well. So both layer 1 and layer 2 are implemented by a typical CAN node in hardware, we could say. All messages that is sent onto a CAN bus can be thought of as broadcast messages, so every node may receive them, and any node is allowed to broadcast a message that anyone else can see. Each single message contains an ID that identifies the source or content of what this message is all about, and every single device, also every single receiver on the bus, decides whether it wants to process or ignore a message. We can do that by using some different filters, and we'll get back to those later.